Okay, so we're recording. Let's continue on. So what I was trying to say during the static E voice is that this class worlds.jar that contains a custom class loader, and that basically changes some of the class loading capabilities of the virtual machine, or a better way to say it is it extends class loading capabilities. So the virtual machine, by default, right, it can load classes off the file system. The class loader in the virtual machine can also load classes off the network by default. But the class loader in the virtual machine is not going to do this. I'm going to look locally for something in my cache, and if I don't find it there, then go to a repository and look for the files in the repository. So that functionality, which is inherent to Maven's dependency management, is kind of baked into that class worlds jar file. And then the other jar file, the Uber jar, that has kind of Maven and all of the supporting classes required to execute plugins and plugin goals. It also contains the super POM that we could go ahead and look at. So those are kind of the key elements for us to be aware of when we're working with Maven. The repository, if we were to go back here and look at Maven installation, you'll notice there's no repository. The repository is an artifact that shows up after I run Maven for the first time, and it's just a directory that's going to contain theoretically jar files. And so over my use of Maven, that repository is going to grow in terms of the number of jar files that are stored locally, and also in terms of the number of versions of jar files that I'm using. So, for example, I could have one project based in Maven that relies on JUnit 3.2.1, and when I use Maven to manage that build, it's going to go download JUnit 3.2.1.jar, store it in the repository. Then I could have another project called Project B that also relies on JUnit, but it relies on JUnit 3.2.3. So when I run that project, Maven's going to look at it and say, oh, there's a different version of JUnit that I have a dependency on versus the one that's in my cache. And then Maven's going to go out, download version 3.2.3 of that jar. So just inherently by me working with two different projects, and those two different projects having dependencies on two different versions of JUnit, I'm going to end up with those two different versions in my repository. So long story short there is that the thing that typically grows the most in my quote-unquote Maven install is this repository. So you may want to periodically do some cleanup if you're really worried about disk space. Otherwise, you can, just move on with life. So we've got baked into the discussion a quick little install lab. If you guys have not done this before, it's worthwhile just to it's not a hard install, but it's worthwhile just to spend a couple of minutes running through the steps of configuring your environment, and then looking at how things are set up. Does that sound like a reasonable 5 to 7 minute exercise?
Maven are the labs running off of?
Say it again.
We have we all have Maven 2 installed. Maybe
okay.
2 or something. Yeah, 2. Some version of 2.
Okay, so you've already got it installed and you can use it from the command line?
Yep.
Okay, so we don't need to do that.
Okay.
Sounds good. So let's talk about the key Maven commands then. So the thing to recognize when we're dealing with Maven is that there are what I'm going to call two different ways for us to quote-unquote invoke commands. There is a syntax that allows us to invoke a Maven lifecycle, phase, which is the closest thing to a command. And then there is a way for us to invoke a plugin goal. So a plugin goal is the closest relationship is to an ant task. So if I wanted to physically invoke like the jar task in ant, in Maven terminologies, I would be invoking a plugin goal. If I wanted to invoke the entire build lifecycle, meaning I'm gonna copy some resources into the correct place, I'm gonna delete all pre-existing classes, I'm gonna then build my new classes, so on and so forth. That terminology is really me invoking a lifecycle command. So could be slightly confusing. Just be aware that there are two kind of ways to invoke these quote-unquote commands. So the key Maven commands, there are truly a limited set, and we'll look through them as we go through the presentation. Maybe there are a total of 6. I don't know the exact count, but it's less than 2 handfuls, so to speak. Generally, when I'm doing builds and I'm working through the build lifecycle, I'm really focused as a developer. I'm working with these lifecycle commands. It's not until I'm trying to debug a specific thing, like I'm trying to debug a failed unit test, or I'm trying to debug a failed deployment to Tomcat or Jetty or something like that, that I'm going to work with these plug-in goals. But generally, it's more lifecycle driven. As far as the execution goes, when I am invoking a command that relates to the lifecycle, I generally just say Maven and then the lifecycle name. So like Maven space test. So it's pretty self-explanatory generally. Remember behind the scenes that when I invoke that lifecycle, what Maven is doing is it's going and finding a configuration that describes all of the associated plugins and goals that have to execute as a single atomic operation for the lifecycle to complete. So in other words, when I say something like Maven compile, behind the scenes, Maven's going to go look at its superpom. It's going to look in the superpom, find a configuration of a lifecycle called compile. Then in that XML element, it's going to look at all the plugins that are defined and then all of the goals, and then it will step through and execute each one of the plugin goals through the entire lifecycle. So when I'm looking at, if I'm trying to make a mental distinction between what is a lifecycle command and what is a plugin goal, visually, whenever I'm invoking a plugin goal, I've got a colon that sits between the plugin name and the quote-unquote task as part of the command string. And when I'm using just a general Maven lifecycle command, it's generally just a Maven and then some one word, like compile, so to speak. Maven-H is a little help flag. And remember, because Maven has a very limited number of commands, that's not going to be super helpful. I mean, it's going to be helpful in that it shows you flags, right? But it's not going to be super helpful in that it's not going to show you every single one of the goals associated with every single one of the plugins. But it can kind of help you get started trying to figure out how to use the tool. If you're on Unix or Linux, you can obviously use the man command, and that'll give you some additional information. Really, more than likely what you'll want to do is you'll want to have the plugin describe itself, and that will give you more information about the plugin and the capabilities of the plugin. But like most things in the open source world, documentation is truly your best friend. So you'll find that some of the plugins, when you tell the plugin to describe itself, you'll see that the language that comes back is very limited. Other plugins have great quote-unquote help, But I found that the external documentation for many plugins is generally better than the describe documentation. So it's just for what it's worth type of deal. So let's talk about your first project. We've got, at this particular point in time, theoretically we've got Maven installed. We've looked at the Maven installation. We've done, Maven-V to see the version information. Maybe we've done Maven-H to see the help information. Also remember that we have in our own user directory, documents and settings / Kelby, whatever, or if I'm on Unix, my Unix path. In my local.m2 directory, I'm going to have my repository, and that repository is going to have some jar files. So that's kind of where we are from just a configuration perspective. Since we have things configured and the environment set up, we can go ahead and have Maven create and manage a project for us. And that's kind of back to where we started, those two things, project creation and then project management. So the way that I'm going to talk about Maven and the way that Maven's documentation talks about Maven is really in the context of a project's lifecycle. It calls out 4 primary different lifecycle phases. Project creation. I'm creating a greenfield project from scratch. Project compilation. So now I'm trying to obviously build a project. Testing, obviously I want to do some unit testing or automated testing with my project, and then packaging. So those are the 4 key kind of project lifecycle phases that I as a developer using Maven will interact with. There are a couple other ones that we'll get to a little bit later on, but they are more from a repository management perspective than they are a software build perspective. The other thing to recognize is that the phases, the project's lifecycle phases are dependent on each other. So, for example, if I were to say Maven, hey, go package my project as a jar, if I haven't gone through the compilation and the testing and so on and so forth, it will go through those phases on my behalf. So there's obviously some inherent lifecycle dependency there. Same thing with test. Test needs to compile, obviously, right, before I can test. So theoretically, if I wanted to create a new project, it would make sense knowing that Maven uses a one-word name for the lifecycles to invoke something like Maven create command. Create obviously implies I'm creating a project. That, for whatever reason, that doesn't work. I guess theoretically the people who designed Maven could have created an alias for a command that worked with a plugin, but this is the only lifecycle phase that doesn't have an associated command. What that means is that in order for me to truly create a project, I need to use something that's called the archetype plugin. The archetype plugin, it is a plugin responsible for going to a central repository, finding in the central repository a specific template that the archetype plugin can use to build a directory structure. So you'll notice the notation here for me to invoke the quote-unquote create structure is Maven space archetype : create. And again, anytime I see that notation, I'm using a plugin and a plugin's goal. So the plugin is archetype, the goal is create. Okay, so all that to say, it would have been a lot more convenient if there was Maven create. Maven create doesn't exist, so I have to use a plugin. Plugin's then going to be responsible for querying the central repository, finding the prototype or the template, downloading the template, snapshotting it, building a project structure. In order for me to do any type of project creation, whether I'm creating a full-featured EJB application or an EAR application or an OSGI-based application or whatever, I have to know kind of what I would call the project's UUID. So before I'm going to go and use this archetype plugin, I as a developer or we as a group have to make some decisions. We have to figure out the group that's going to be responsible for the project. There is no, let's say there's no real naming convention here. Some of the companies that I've worked with use, the actual group's name, like did some work at level 3, for example, and they have a GIS group, so their group ID was GIS. Okay, it only makes sense in the context of level 3. That's fine. Other companies get a little bit more specific. It's entirely up to you. Okay. The second thing is artifact ID, and that basically defines the library name. That's the easiest way that I can describe it. So is this the Apache's Common Library? Is this the Jasper Library? Is this the Servlet Library? Whatever. It's the library that people will use, the brand name, so to speak, of the project that people are going to use. So I've got to define who's working on it. I've got to define what the product's going to be called or project's going to be called. And then obviously I need to define the version that I'm working on. Generally I'm going to start off, in all software development, I'm going to start off with some dot release. That's usually how we start, 0.0.1, so to speak. And then we increment the version manually, as we get closer to a beta release or alpha release, beta release, so on and so forth. And then usually when we do first customer ship of our project, we flip over the first octet to be a 1, and then it becomes 1.0. something. In Maven, we can adopt that versioning structure, but there's a little caveat that we need to be aware of. Because Maven does dependency management for us, it's going to take the version number very literally. So if I wanted some wildcarding to happen later on in my application, I need to make sure that I set up my project structure all the way through to support that wildcarding. And we'll get to that later on. My suggestion is that you actually start off with a version 1.0 instead of the 0.0. something. And you'll see why a little bit later on. The last thing that we need to be aware of is the type of project that we're building, right? So the archetype artifact ID. So in general terms, am I going to be creating a standalone library, a jar? Am I going to be creating a web application at war? Am I going to be creating a standalone JPA application, another jar, so on and so forth? I need to know that in advance, because when I work with the archetype plugin, I need to tell the archetype plugin what type of archetype template to use to build out the project structure. Okay, so and that's a reasonable expectation, right? I'm not going to sit down to write code without knowing the type of application I'm building. So that's a reasonable expectation. So with that information, with the with my who's going to build the project, what is the project going to be called, what version am I working on it, and what type of application am I working on. With all that information, I can go back to my archetype create command, so to speak, and specify. So you'll notice here a very complete syntax is the first example. Specify the group ID, artifact ID, version, so on and so forth. If I wanted to adopt a well-known packaging convention, org dot whatever dot whatever dot whatever, or com dot company domain dot whatever dot whatever, I can specify that there. Or if I just want to be lazy and have the project structure built, knowing that I can go back and change things in the future, I could use this kind of simplistic syntax, which is the second example. A couple of quick things to note here is that if I use the simple syntax, again, remember Maven adopts intelligence over configuration or convention over configuration. So Maven's going to assume that the archetype you're trying to create in the simple syntax is a jar file, and that it's going to assume that that jar file is going to contain a standalone Java application, which, to get something started isn't necessarily a bad thing, but just be aware of that. Second thing is that recognize that Maven's going to assume a default for a version. So it's going to version it. Most recent version of Maven that I used defaults the versioning to a snapshot version. which is kind of a wild carding type of syntax. So it's just going to make some logical guesses. Again, I can change them in the future, so it's not a big deal if I have to change them. Questions?
Sure. So this is not, this is a dumb question, right? So this is not reading a plum. This is going to generate a plum. Is that right?
That's correct. Exactly correct. Yep. Yep. That's a good question. And that so just to make sure that everybody's okay with the definition of a POM, we're talking POM from a project structure perspective, which includes pom.xml and all of the directories and all of the meta directories and inf directories and whatever related to the archetype that I'm working with. Right? Does that make sense?
Yep.
Okay. Okay, good. So here's here's a very simple example using the Maven archetype create. I specify the group ID, specify the artifact ID, group ID, just using DevelopIntelligence convention. Artifact ID, just using the project name convention, Hello World. Everybody's got to do a Hello World project when they adopt a new technology, right? And then what you'll see here is that if we were to just walk through this kind of line by line, you'll see first thing here is that Maven's going to look for a plugin called archetype. If this is the first time I've ever run Maven, just say it was, it is possible that Maven will go out to the central repository and download that archetype plugin. And then once it downloads that archetype plugin and quote-unquote loads it into memory, then it will go ahead and try to use the plugin. Okay, so let's say that the plugin exists. In this case, let's say it exists. And then the next thing that's going to happen is that it's going to start to execute kind of the archetypes. Let me get this arrow back. Execute the archetypes goal. And what you'll notice, kind of from right here, using following parameters on down, that's just the archetype plugin, spitting out information so that I can see what the defaults are. Remember, we only specified the group ID and we only specified the artifact ID. So the rest of the stuff there, right, is just defaulted with some natural value. And then somewhere along the way, right, the goal is actually going to do whatever the goal needs to do. In this particular case, it's going to build a directory structure called Hello World. In that directory structure, it's going to build some subdirectories with some files, so on and so forth, and then I'll be done. Okay, so that's the basic flow. And depending on which archetype I'm creating, it might be that simplistic, or it might be more complex. But generally, it's going to work like that. So to summarize, summarize what we just talked about more formally, we talked about how Maven looks for the plugin, downloads it if needs, updates if needs, and then executes the goal. So the interesting thing is that if this were the first execution of Maven for you to first execution of Maven and the first project that you're going to build, if you were to go look at your repository after this archetype create call, you're probably going to see that your repository, your local repository in that .m2 directory contains a bunch of different jars. We as developers did not specify any of these jars in the command line. We didn't tell Maven, hey, we're going to use JUnit. We didn't tell Maven, hey, we're going to use the commons packages. Maven, or in particular, the archetype plugin said, hey, I've got all these dependencies, and told Maven, go get these dependencies for me from the repository so that I can execute the goal. So that's, when we get to the lab, that's something that's worthwhile to look at. It's just kind of interesting. It's not like you're going to save the world by reviewing the repository, but it's kind of interesting to see how that works. From a project perspective, obviously we're going to be more interested in what in the world did Maven's archetype plugin create for us. We know based on, or hopefully we know based on the console output, that it created a directory called Hello World. I mean, it told us that, so that's great. But what we really need to know is what did it place in that Hello World directory. Well, first and foremost, we need that Hello World directory to represent a valid POM. And the way that we're going to do that is to include in the directory a pom.xml file. Again, this one's created on our behalf by the plugin. Because we didn't specify the actual archetype, we didn't specify the type of application that we're working with, remember that the archetype plugin assumes intelligent default, assumes that you're going to create a standalone Java application. The Java application is going to have a file that's going to have public static void main, so on and so forth. So you'll see that the archetype creates my source directory. It's going to use some values for my package structure based on the group ID that I set up, creates that skeleton of the application for me. And then, again, Maven's going to assume, hey, if I'm creating any project, any software project, I'm going to have to do testing. So it creates, as a peer to source, the test directory. And the test directory obviously is structured properly for segregation of production code versus test code. And there's a sample test application. So that's the directory structure and the artifacts in the directory that it builds on my behalf. So it's kind of the first thing for us to be aware of. And again, because we're thinking of Maven as a project management tool, it's also worthwhile for us to understand what's in the POM. So if we were to open up that pom.xml file and we were to look at it, you'll notice a couple of things. One is that the archetype just creates, the general UUID for my project. And again, we define that based on the group ID, the artifact ID, and the version. We specified two of the values, group ID, artifact ID. When we started this discussion, I said, hey, be aware of the fact that when we use the simple notation, Maven's going to default the version to a snapshot, and it's going to default the packaging to a jar. So you'll see in this actual POM that is true. And again, we'll talk about what snapshot means a little bit later on. Packaging in a jar, obviously there's different options there, war, EJB jar, EAR, so on and so forth. And then some of the other stuff that it created on our behalf, what's the name of the project, what's the URL of the project. Obviously, I don't want my project to go to Maven. I'd probably want to change that. Some encoding issues. Macs have different encoding, which can cause problems from a compilation perspective. And then the big thing here is that I didn't tell Maven I'm going to do unit testing. I didn't tell Maven that I'm going to use JUnit for unit testing. But the archetype for jar said, hey, you know what? Most of the time when people create standalone applications, they use JUnit. So the archetype create goal creates a dependency in that POM for us, and in that dependency it calls out the fact that we're going to use JUnit. And in particular, it calls out which version of JUnit we're going to be using. So you can see, just from a very simplistic perspective, I execute a single line command behind the scenes. My directory structure is built. It's a valid directory structure because it's got a valid POM. The POM is pre-configured with some key information, and the POM is pre-configured with some unit testing dependencies. And then the last piece, just to complete the circle of knowledge here, is that the source code that is generated is truly skeleton source code. I didn't do anything to the source code. It's generated on the archetype's behalf. Just realize it's starter code, right? It's not intended to be the entire application. Any questions on that little discussion?
I think we're good.
Okay. So my suggestion is that we actually do this lab. But before we do this, let's actually talk about the compile command and then how to run the application. That'll allow you to do two things. One is it'll allow you to create the project, and then two, it'll allow you to compile it and run it. It's a little bit more complete of a lab than just building the project structure. So if you can bear with me for another, 12-ish minutes, let's talk about the compile lifecycle, and then we'll do a lab. So remember I've got the create lifecycle, I've got the compile lifecycle, I've got the test lifecycle, and I've got the package lifecycle. We just looked at the create lifecycle and the execution of that through the archetype plugin. Now we're saying, hey, we have a valid POM. We don't necessarily know that it's a jar. Maybe it is a jar. Maybe it's a war. Maybe it's an ear. But we want to compile the source code in that POM. So the way that I do this is very simple. Maven compile, and it's going to go ahead and look when I invoke that compile lifecycle command. It's going to go look for my pom.xml file. So I need to be in the right directory. Once it finds a pom.xml file, it's going to build the source code properly based on the POM's definition. So you can see here, when we look at the output here, the compile lifecycle is just going to build a single class because we only had one single class in our source tree at the moment. It does not build the test classes, and the reason there, right, is that testing is its own separate lifecycle in Maven. So once I execute that lifecycle command, again, same type of deal happens. If plugins are missing, Maven will download them. If dependencies are missing, Maven will download them. Then it executes the compile plugin, executes a goal with the compile plugin. As expected, classes are going to go in the classes directory, source is going to stay in the source directory, so on and so forth. I should be able to look at my directory structure now and see I've got a target directory created, and in that target directory created I've got classes, and now if I were to expand the classes tree, you'll see I have a compiled representation of app.java called app.class. So now I've got a valid class, and if I wanted to, I could go ahead and just execute the simple application. In this example, I'm using the -cp command line argument to execute, hello world, our hello world app called app. So that wasn't quite 12-ish minutes. That was a quicker walkthrough. Are there any questions on compile?
I think we're good.
Okay, so let's do both of those labs. So the compile, and let's do the archetype create, and then once you've created and you've inspected what was created, then go ahead and do the compile and run. I'm going to actually slide the presentation back to the archetype create command, because that's what you'll want to use as a reference for the lab. So call, just to be consistent with the book, call your artifact hello world. You don't need to adopt the group ID com.di.maven. Adopt whatever you want there, but at least make the project have the same name, hello world. And let's say, go ahead.
Kelly?
Yep.
Some people are going to have to go back to their desk to do this. So is this in the PDF that you sent out?
It is in the PDF. Yep.
All right. So
I mean, the other option there, because you guys, you guys just huddle around the one PC that's connected to the projector. And then you just, go through it as a group.
Okay, yeah, so we can do it kind of on a team basis then. Okay, that's good.
Okay. So my guess is that it's probably not going to take you, the full 25 minutes that are allotted for the 2 labs. So what I'm going to do is I'm going to stop the recording, leave the phone bridge dialed in, so on and so forth, and then when you guys feel like you're good, just shout at me on the phone or raise your hand.
All right. Good.
Okay.
Don't do the technical. You want to do it here? Yeah.
Thank you. Please stand by.